If you look on the screen, you can see all these objects floating around. This is actually the result of a clever idea that somebody had a long time ago. If these objects were actually objects like we create, spheres and rectangle cubes and cylinders and so forth, the amount of computer time to build them would be enormous, because they have to build them in 3D, because cylinders are 3D, and then the computer has to put them on the screen, has to flatten out the image and project it onto the screen. That all takes arithmetic and it takes a long process. But here we have a case where we have a huge number of these things, and in fact, there is an example in our website, which I'll look at later, that has 150,000 of these objects on the screen living at one time and all moving properly. So here's what they did. They got this clever idea. They said, well, what if, because of the fact when you have an object, it has the points that actually construct the object, like suppose it has 200 or 300 points like that. They said, what if instead of filling in the object, what we simply did is we took those points, which we have to draw anyway, and we just put a picture on those points, a little picture on each one of those points, the same object. So for example, if I put a picture of a tree, I could put a tree on this point, and a tree on that point, a tree on the different points, and then what would happen is that tree would project on the screen. The advantage of that was this: it's not a three-dimensional tree, it's just a flat object, just a flat image, and they just put it in the position where the points are on the object. And so what happens is when you move, like, and you change, like for example, when we look around here, if I turn to a different direction, notice no matter what direction I look in, the objects are always looking at me. They don't change positions, because what happens is, the way this works is, they make these things called sprites. They're called sprites, and sometimes they're called particles, like particle system. They're called particles. Either were interchangeable for us. They are distinct, but for us they're the same. So you have these particles or sprites, and what it means is it's a little picture, and wherever you move, that picture always looks at you. It never looks away. So it gives you the impression it's three-dimensional, but it's really not. It's just a flat object, okay? Well, it turns out that that's extremely useful for a lot of stuff. And so what I did was, I don't know if you, how many people here have actually looked at the website this week? Did anybody look at it? Did you look at it? Have you guys looked at it? You see there's a bunch of programs there that use these things. They're just demonstrations, I mean, but there's lots of ways of using these particles. So what I want to do is, I want to show you two things today. One is how to make the particles, how to make these particles and how to, put them together. And the second thing is, I want to show you what scaling is, what it means to scale something, which means make it bigger or smaller, okay? What we've had so far, there are three ways of talking to an object. You can position it, tell it where it is. You can rotate it, tell it which way it's looking. Or you could scale it, which makes it bigger or smaller. Those are the three operations that we do on. And so we haven't talked about scaling because we didn't have any need for it. But now, I use scaling for various things, but I'll show you how scaling works, and I'll show you how the particle system works, and then you can just use them if you want to use them for anything you want to do, okay? The first thing that comes to mind with particles is snow. That's an easy thing. You make a big bunch of particles, and then you can make them move. You can also see, because the particles are like one object. Like if you build an object, you can rotate it. And if the particles are simply the points on that object with a picture on them, then you can see if you rotate, the pictures all rotate as well. So you can sort of make objects move around different directions. And what you're looking at here on the screen is there are three kinds of particles. There's the red ones, the blue ones, and the green ones. And what I've done is I've created a bunch of particles, and I had one of them rotate over its x-axis. All the particles are rotating over the x-axis like this, and some particles are rotating over the y-axis, some over the z-axis. So in other words, the particles, these three different colors, are rotating, and it just looks like a confusion. But really what it is these particles have been generated randomly all over the place, and they're just moving in between each other. Now, another thing you can see here is that when a particle gets in front of another particle, it blocks it, just like you expect something in the front to block. Now, you can think this through. You'd realize If that was just a regular picture, it would have a frame, and the frame would get in the way. It would block, it would look stupid. So basically what you have to do is all these particles have to be ping. You have to make them and put them into ping format, and you have to erase the stuff around the edges, the frame of the thing. And that's the only way you really can do it, but that's how it works. I haven't rigged this thing yet to take animations in the particles. That can be done. You could have an MP4 in the particles, but I haven't set up my system to do that. So at this point, what we have is the ability to put the particles with images. It's got to be an image. You've got to have an image of some kind, and you can put them up that way. But that's the only thing you can do. Particle size is another question. When you scale particles, what you're doing is you're scaling all of them. All of it's like a cloud that's getting bigger or smaller. The individual little guys, you have to tell them what size you want them. And in this format, in this particular language right here, I believe the restriction is in units, it's 64. So you can make your particles anything from 1 to 64. And that's based on, you have to look at it to see what that means to you, but that's essentially the possibilities. And 64 is a magic number in computing. It's 2 times 2 times 2 times 2. Everything that's binary in computing. So 64 was the number they chose. It's possibly because when they had smaller computers, that was an upper limit for what the work they could do somehow. But there it is. That's what we have. And so now I'm going to show you 2 things. First, I'm going to show you scaling, how to scale stuff, because that's not only useful in an object. I can change the X, Y, or Z of an object, but I also can scale a cloud of particles. I can scale them all up bigger. The individual particles will be the same size, but the cloud will be larger. Okay, it'll be scaled out. So let's start off with scaling. How you do scaling? Okay. What's that say? Let's get rid of that. I don't know what it's doing here. Okay. Well, we're still getting it. That projection is from that screen. Let's take it from my screen, see if I can get it over there. Okay, you're on my screen now. All right, so the first thing I want to do is I'm going to create a little program with an object of some kind, and then I'm going to apply scaling to the object to show you what it does. Okay, it's kind of a simple idea, but I want to just do it one time to show you how it works. Let me see if I have a program that's already here that we can actually apply it to. Didn't we build an object last time? I think we did. Let me just see what I've got. Box color, farmhouse, Hawaii, zoo. I don't think any of those had an object in them. Did they click the color? Maybe that one did. Let's see what that is. I think, yeah, that sort of had something. I'm going to get this commercial out of the way here. They're trying to protect us from viruses. They're worse than viruses when they come after you. Let me just see what this looks like. It's running a little slow. These things don't run as slow on your machines. The reason why I'm running slow is because I'm trying to take a picture of the image at the same time. It's missing some artifact there. Let me try one more time here, see if I can get it to recharge. No, it doesn't like it. Okay. I might have to write another program. Let me just see what I've got here. What else I've got? Box color. Right. Fire. No, that was the zoo program doesn't have Hawaii doesn't have a farmhouse doesn't have an object. Somehow I don't have any objects in this group here for some reason. Okay, I'll bring it. I'll make a wall maker program. It's probably worth the time anyway. Let's just make a wall maker program. is. I'll just put a floor and a ceiling on it, and we'll get out of it. This thing here. I'm trusting you guys to watch my typing because I can't actually see what I'm doing here. I like to, like one of those pilots that doesn't see what's going on. A pilot from Southeast. Okay, where are you? Here you are. All I've done there is set this thing up, put it at the desktop. Let's call it scale.html. Okay, save. Okay, there it is right there. It just came in right here. That's it. So now we have the program called Scale. I want to put an object in it. We should put a cylinder in. Put a cylinder in the thing. Cylinders are nice because you can stretch them and you can see what kind of happens to them when you work with them. So let me add a cylinder to it. That's the object that we use that to scale. And so whether you give it the X, we've got 20, 20, 20, 20, 32, 32, and let's put an image on it. Oh, I got to get an image. What have I got? Hang on for a second. I think I do have a picture I could plug onto it somewhere. Try box color, see what that does. You got to get an image that kind of, let's use Venus map, that'll be kind of fun. It's a weird one. Copy. V. Okay. I'm just going to use that image to put on the cylinder. It's called Venus map. Okay, I've got to close this, do that, /script. Close. What?
I think you need one of the bracket symbols after the JPEG and the parentheses as well, right?
What'd you say? After the JPEG? If you want to put something after the JPEG, what that does is it kills the top and bottom of the cylinder. If you put nothing there, the cylinder will fill in everywhere, top and bottom, with the same.
Never mind. I actually misread it. I didn't see the other one after the word script. I just saw the one before it.
Oh, you mean like one of those little V things here?
Yeah.
Sure. No, you don't need it. You got it up here. You got it right here.
Okay.
You know, that has been a problem online with people, by the way. Like, see this one right here, this upper one right here, the script opens, but it doesn't shut. This is all wrapped within the script tag. That is a weird one. That's the weird one. And so people have done that. They put one of those little chevrons at the end, and it's caused trouble. I don't think I can get around that. I don't think there's any way to get around that. So, okay, so now I have this silly, and it's a tube. Let's put it up here.
That's really what they call it.
What?
The silly tube.
Silly. It's a tube, a cylinder, right? Okay.
It just seems very odd for programming.
Unfortunately, these names, you guys, are historic. They come from when I was doing it for other things in the course. they just became what they were. And they had programs that were already using those things, so I couldn't pull them out because their programs would all break. So I was stuck with whatever we came up with. That, by the way, that's exactly what's true of HTML too. Do you ever wonder why it says HTTP and all that stuff? That's all junk. It's just that in the beginning they didn't think it through and they didn't realize what that was going to cost, but that's what happens. Okay, so we have a tube. Let's see if I can get the tube in front, see what it looks like. I'll run the program. Oh, yeah. Good for you. Yep, I didn't do anything. Make these changes. I think the thing's going to think for me, but it doesn't do that, does it? Z, Y, Z. And this is a rotation. You probably noticed I also pulled the last class and replaced it with what I consider a better version. I don't even know if I was awake that day. When I started to watch it, I said to myself, my God, they could use this at Guantanamo to torture.
I think though at the same time, I think we all just ate like hearing our own voices on recordings.
Yeah, well.
I know I certainly, like, I can't stand speaking on video if I'm going to hear it again.
Hang on, let me just see what we got here. Okay, back up because I'm at the 0 position. And there's the cylinder right there. So if I just go up and take a look at it here, go forward a little bit. You can see it down there. So that's the cylinder. It's kind of awkward, a little bit awkward, but it's okay. It's not too bad. Okay, so now the cylinder's sitting there. Supposing I already set the cylinder up its size. I already said I want it to be 20, 20, 20. But supposing for some reason I wanted to stretch it in some direction. Supposing I wanted to scale it, and I want to scale it in the Y direction. I want to stretch it in the Y, make it twice as big as it is. Okay. So here's what you do. You go into the program where the object is located. This is it right here. And before you start to display the object, you start to position it and everything. You say silly dot tube dot scale dot y, we're going in the y direction here, dot y equals 2. If I set scale y equals 1, it would stay the same size as it is. If I put 2 there, it's going to double it. Put 3 times as it. And use fractions to get smaller, and a negative number inverts it. It does the inversion you expect. It pulls it inside out. And so that's, but you can experiment with that if you want to. But all I've done here is I said, let's make it twice as tall in the y direction. And let's see if it looks like that. So I'm saving this. Good. Do you have a question?
Well, you answered it later. I was going to ask if you put like a decimal or a fraction in, if you could miniaturize it as well.
Which I add, yeah, which is true. Yeah, we'll do that too, just to do it. Okay, I'm going to back up again. I'm going to set this. See how it looks. You can see it's much bigger now, taller than it was before. Let's do that. Let's make it a fraction on the height. Let's make it like 0.1 of what it was. We'll make it very small, so it should come out like a little cylinder, a little tiny flat cylinder. In that direction. But you can use the other directions too, by the way. I'll do that in a second. I just want to make it 0.2 because you already got the 2 there. So I'll make it pretty small. Try that and see what it looks like. It's just a little flat cylinder. Now here's where it gets weird. This thing is scaling in the y direction. If this object was a child of another object, however that object scales is the way this object scales as well. In other words, the entire thing, whatever child it has, goes through the same operations. Okay? But the really weird thing is, when you turn the thing in a different direction on its own, if I turn the thing on its own in a different direction like that, what the long part will shrink back to normal if I make it, because it's thinking of the parent. And it says, the parent says, in this direction it's shrunk, in that direction it's not shrunk. So originally it would be shrunk, I'm sorry, let's say it's extended. So if it's extended in the y direction long, as long as the parent's pointed up, if I take this thing and tip it over like that, it's going to shrink in this direction, but it's going to go back to normal in that direction. So in other words, whatever, a child is a weird thing in scaling. You got to be really careful, because it might not do what you expect it to do. If you move it according to its own standards, because it knows where its x, y, and z are, it knows where they all are, and it acts according to those standards. But if the parent moves, it acts according to its standards. It decides what to do. So you got to be really careful with that. So I suggest, by the way, I'm going to tell you right now, I only use scaling for weird things that I want to do, something peculiar. You don't want to, for example, if you have a cylinder and you made it 20 by 20 by 20, and you say, oh gee, I wish it was 40, and just scale it double, that would not be a good thing to do, because it introduces problems that you might not anticipate, and it's not worth it. It's much easier to just say, make the thing 40, and that's all there is to it. And it saves you another instruction. Let me, just for the sake of doing it, let me change this to the x direction. Now, when I do that, it's going to turn this into not a cylinder, it's going to turn it into a kind of a oval-shaped vertical thing, as you'll see in a second, because it only shrinks in the x direction. It doesn't shrink in the z direction as well. If I did it in both the x and the z, then the whole cylinder would get to be a little smaller cylinder. But this won't happen here. It'll look like smaller from this direction, but when I move around, it'll be different.
So it becomes more like an oval per se instead of a circle?
Yeah, let me back up a little bit here. See what it looks like? Let me go up a little bit and take a look at it. You can see what it's done. So you know, it shrunk. It did shrink in the x direction, but it's still the z direction is still the same. So it has so you can sort of think that here's another thing that scaling does for you. Sometimes you want to make an object that's got some kind of funny shape to it, and we only have cylinders, spheres, and blah blah blah. We only have a few things. By judiciously using this kind of thing, you can build other kinds of objects. So in this case right here, you can see immediately that, for example, if you want to build a propeller or something, you could make a long cylindrical kind of, flattened cylinder kind of thing, which wouldn't be quite like a propeller, but it would be better than using a simple cylinder for a propeller. We've got restrictions in what we can do with the number of objects we have, but you can see that it is possible by using scaling to get a little bit more flexibility out of the kind of objects we can make. Now, that's how you do scaling on a solid object. But let me introduce the idea of particles, and then we'll make some particles, and then we'll scale them and talk about how they scale, okay? So this is a solid, everybody, is that clear, pretty clear? Yeah, question?
Is it possible to make your 3D space appear to shrink or be larger?
To do this manually, you mean?
Yes.
Yes, it is. In fact, I have these things I call the explosions. Do you see those online? Well, okay. You can make explosions, and what you simply do is this: you have a little sphere made. You take all your particles and cluster them, make the particle feel very small, and then what you do is you say, expand x, y, z, all those particles quickly, like as you're running, and they all go like that. They all expand. So in other words, you can use scaling dynamically too. But what you're saying is, if you want to press a key and you want something to change size, right? Yeah, that would be good.
What about your entire 3D space? Would it be possible?
Yeah, you could have like a picture of a person there, and when you press the ice cream, they could go like that. when they press the smoking, they could go like that. Yeah, you could do that. Yeah. It'll do what you want. Okay, so let's do particles. I'm going to use the same program. I'm just going to get rid of the thing we just created because we don't want that. So I'll get rid of this thing right here. Actually, I could just change it from a tube to something else, couldn't I? Let's do that. Okay, there are two kinds of particles you can make. Let me get rid of this first. And I have to tell you, what I've done is I have simplified this thing. In the real language, you can actually create one single particle. and you can have that one particle and then a different particle and a different particle, and you have them do different things. You can do that with us too. You can do the same thing. But what I do is I assume you're going to make anywhere from 1 to 500,000 particles. I don't know how many you're going to make. So I give you the option to make as many particles as you want. You could choose one if you want to, or you can choose as many as you want. But what we're doing is we're taking the whole structure, and when it rotates like this. The whole structure rotates. When they create one particle, and there is a way of doing that, which we're not doing, they can turn that one particle like this. But we can do the same thing. Instead of creating 50,000 particles, we can create one, and then just take that whole system and turn it. There's only one object in the system, so we can rotate it, and it looks just like what they do. In other words, the difference between what they do and what we do is simply that I use one instruction to create 1 or a billion. It's all with the same instruction. They have 2 different instructions. And so I departed from that because it requires a different kind of programming, and I didn't want to get into that. So what I said was, okay, what we'll do is we'll have one instruction, we'll create particles. But then all of a sudden, after I started doing it, I realized I needed 2 different instructions, and here's what they do. One instruction creates a cube of particles. It's shaped like a cube, because there are times when you need that. And then I created a second instruction, which creates a sphere of particles. Now, that sphere isn't full. You can say to the sphere, I want to, like, for example, supposing you're a planet, you can say, I want to start the particles 600 miles out, and I want the particles to end 800 miles out. So you're going to get a sphere around the thing, but the empty space between the planet and the particles. Does that make sense to you?
Like
So,
the planet's ring, for example.
yeah, you have the ability to do this. So in other words, when you create a sphere, it doesn't create a solid sphere of particles. It creates a ring of particles, 3-dimensional ring, okay? Which you can make solid if you want to. You can say, I want to build the particle sphere from 0 to 200, and it will do that. It'll create particles everywhere in between. So you tell it the top and bottom of the what?
Oh, that was just a stretch.
Okay. So let me let's start off with the sphere sprites. Okay, I'm gonna make a sphere of particles. First thing you have to do is you have to have an image of some kind, and we had an image there for a minute. Let me see what I got. I got bricks. Let's use the bricks. It's a little. The bricks is right here. We've got it. I mean, what the particle is that making a difference. Let's use that as the image. Okay. So I'm going to say, okay, I'm going to make a bunch of particles, and they're going to have little pictures of bricks on them. Okay, so first thing you want to do is you create what you call a sprite sphere, S-P-R-I-T-E, capital S-P-H-E-R-E, sprite sphere. So we're going to create a ball of particles, okay? The first parameter in the thing is how many particles do you want? As I say, you can put it from 1 to 100,000. It'll do it. It'll create them for you. I should tell you this though: if you create 100,000 particles, it is a slower process to draw, but it still seems to be pretty good in real time. It may be a little bit slower, but it's pretty good in real time still. I usually keep my particle counts in the thousands, because once you get to a few thousand, you pretty much have filled up the screen with debris anyway. I mean, it's all filled in. If you build 50,000, I mean, the stuff is distant. It gets so tiny you don't see it anyway, so there's not much advantage to it. If you try it a little bit, you'll see what you get. Let's see. I'm going to give it 4,000 particles here. Okay, 4,000. And so that's the first thing it is. How many particles are there? The second thing I have to do is I have to say the sphere goes out the maximum radius. What's the maximum radius of the sphere? Okay, that's the first.
Would that be like the outer ring of the planet in that case?
What?
Would that, when you say maximum and minimum radius, are you referring to like the planet's ring, the outer?
Yeah, if it's a sphere of particles, it's the longest. The particles will fill everything up to that length there. The particles will fill up the entire thing.
So that's the outermost.
Yeah, it's the outer radius, right? I'm going to use numbers here that are kind of similar to what I've been using. So let's 4,000. Let's make it 500. So I'm saying the outer limit is 500, and let's say I want to make the inners. What it means is now you got a sphere out here, but if you want just to be empty in here, you have to have an outer radius and an inner radius. Then it creates this sphere. It's like a wall rather than like a solid sphere. So you pick a smaller number. If you pick a number close to 500, smaller, it'll create just a very thin one. If you use it like, for example, if I put 499, that layer will be very, very thin out there. If I say 400, let's pick 400 so it'll be visible to us. So what I'm saying is I'm going to have 4,000 particles. The longest radius is 500, the shortest radius. So these things are in orbit between 4 and 500 from the thing. And then what I want to do is I want to say the size of the particle. That's where you go anywhere from 1 to 64. Pick the size you want. You have to look at them. If you don't like it, change that size, and you can do a different one. Let me make sure I get this right now. Dimension and image. I think I do. Okay. I have made changes in these things, so I don't want to get myself confused. So we're going to use bricks. .jpg. And then close that, semicolon, / script. Okay, so that's it. So that's a sprite sphere. Creates a sphere. Wait a minute, I didn't put the last number in, sorry about that. I got to put that, the size. Let's pick 8 for a size, just for, I don't care what size it is, but that would be about right. You understand what I'm doing? That last number is how big the actual sprite is on the screen. Okay, and it doesn't make any difference, by the way. It doesn't make any difference how big the image is. But if I were you, because of the fact that it's going to be so many things, I would pick a very small image, something that's not very big. Don't pick something that's 4,000 by 3,000. Pick something that's like, 50 by 100 or something like that. Small numbers. Better off, because you can't see it anyway. It's going to be so small you won't be able to see the detail. Okay, so we've done that. Now what I have to do is I have to create the particles where they're going to be. Oh, I'll give them the name Silly. I gave the name Silly. Okay. Up here, what I do is I call them, the name is Sprite Ball. So this right here is going to be Sprite Ball. That's their generic name. Sprite, B-A-L-L, capital B, Sprite Ball. That's the generic name for these objects. Okay. You see what I'm doing? I'm just trying to cheat by using these previous thing here, because I'm so good at it.
So you just copied and pasted from the silly tube, and you're just changing that.
What?
So you just copied and pasted from the silly tube,
just,
and you're changing it.
Just
okay.
cheap editing trick, right? Okay. Which when you watch me klutz my way through this, you guys might not want to do this. I don't take all the claim, all the claim for working so badly up here on the computer, because I have this mouse that's falling off the edge all the time. I only had about a half an inch over here, and it's driving me crazy. That's what's actually driving me nuts. I can't use my finger pad because it doesn't work for me. Okay, let's see what we got. We got the thing ready. Let's see what happens. Oh wait, everything's all set right. Let's see what happens now. This ought to be interesting.
You still have a scale on there named silly.tube scale.
Oh, did it scale? Is it alive still?
Yeah.
I didn't shut it down? Okay. Those are going to be very small particles. Maybe so small we won't even be able to see them. Let's redo this. Oh, I know why. It went blank because it saw the tube thing. See, there is no tube. Didn't like that. So let me just kill this. And I'm going to change its name. I'll change its name to Sprite Ball here. So we can actually do this if we want to. Okay, does that look good? Let's try it again. It wouldn't have drawn anyway because it didn't like that tube. If you leave any debris from other programs, you have to get rid of it because it's going to say, oh, I can't find that. And it just stops, won't run. There they are, out there, sticking out there. And they're not doing anything, they're just sitting there. If I get closer to them, I can't get very close because they're out beyond the pall here. We're in, they're just little brick windows, that's all they are, little bricks. And notice no matter which way I look, they're always looking at me. They won't look in any other direction, okay? I should get rid of, I'm going to get rid of the floor and the ceiling because I think That's going to get in our way here. So let me just kill those guys. Right here. All right, I'll get rid of them all. Okay. I'll just erase them all because we don't need them for anything. Down here, floor and ceiling. See if that looks any different. Yeah, there they are. The world is full of sprites, and it's everywhere. It's a sphere, okay, out there. Let me...
So you were inside a sphere in this case?
Huh?
Are you like inside a sphere per se then?
We're in the middle of it.
Okay.
And they're out on the outer edge. They're out, what do we put them, 700? They're way out there someplace. We could bring them in closer, but let's do something else. You might want to have the sphere rotating, so that it just gently rotates, so everything's kind of moving around in a circle, okay? All you have to do is you just treat the sphere, you treat the sprite ball just like it's an object. It's got rotation. So it does. So right here you have rotations right here. So if I just simply say at this Y position right here, if I simply say plus equals 0.1, whoops, that should be a 0.1. 0.1. If I do that, what's going to happen is every time it draws the picture, it's going to add 0.1 to the Y rotation. So the thing's going to start slowly rotating around. Okay, so the entire sky will rotate. All the objects will rotate in that direction, which is the way that original image was. The original image worked. I can get this thing here. Okay, try that. There it is. The original image, all it simply has, it's going to do exactly what we're doing now, except that I had 3 sprite groups, different colors, different images. One of them was rotating over the Y, one's rotating over the Z, and the other one's rotating over the X. The 3 different groups are rotating, but we only have one group here, but we should be able to do it with that one group, be able to show you what it kind of looks like. So let's just run this as it is now and see what happens. Now, I'm saying that the sprites collectively are an object, and they're going to act as one object. They're going to rotate as one object around you. You're at the center, so it's going to rotate around you. Pretty fast, too. I think it's 0.1 is pretty fast, apparently. And there's the South Pole down there. And, where's that? Don't look at it. You can see that this is good for hippie stuff. Yeah, so there it is. That's how you do that. Now, a next question might be, except just rotating, you might want to scale the thing different ways. You can do that. But here's what I want to do. So it's very often the case that you want to make something blow up. That's a pretty common thing to want to do. So what you can do is, you can't make a physical, like for example, if you make a bomb, the shape of a bomb, that bomb is not going to blow up unless it's made out of sprites, in which case it could blow up. You could make it out of 150,000 sprites. It would be consuming, but you'd have a bomb there, and then when you press a button or key, you can make it go poop like that and just blow up, okay? Possible to do that. Let's do it. Let's do the math for it. That actually is a programming thing that's commonly needed for stuff. You want to press a key, and you want something to happen, and then you want it to stop. Like, for example, you want to hit a key, have the thing move someplace, and then stop. Then you hit the key again and move someplace and stop. You want to be able to do that. In order to do it, what you have to do is you have to have a variable someplace which controls whether or not the thing is active, whether it's actively doing something. So what happens is when you press the key, it says to this variable, which you start off as 0, you say turn that into 1. And then down in your rendering program, you say, if that's 1, do this. You start doing stuff to it, okay, every time you come through. And then what happens is, when it does as much as you want to do, you have another little if statement there that says, well, if you reach whatever limit that you want to reach, 6,000 or whatever iterations, you say if it's 6,000, then set that trigger back to 0 and set all the objects back to their original position. So in other words, what you do is you have a variable, and when you click a button, it changes that variable to 1, from 0 to 1. And as long as that's 1, it keeps changing something in your program, in your renderer. And so finally, when it reaches a certain point, you're constantly looking to see how high you've done it. And when you reach a certain point, you say shut it off, and it shuts it off. And it's all set to go again. Then you hit the key, and it'll do it again. So the thing is, you got 3 places you got to worry about: creating the variable, having the if statement saying when you hit a key, do something, and then in the rendering program, you have to say, as long as this thing is a certain level, do it, but keep checking to see what level we're at. When you get a upper limit, then shut it off. That's the tricky part, is down in the rendering program. But let's write it and see what it looks like. Supposing, for example, we wanted to make these sprites right here a bomb that goes off. First thing I'm going to do is I'm going to say, well, I want 4,000 sprites, but I want them to be located at 0, 0, 0, and 0 here. So what I'm saying is, I'm going to have this little ball you can't even see of sprites. They're all going to be clustered right there. And then what I'm going to say is, when I press this button, make them go poof like that, out from the center, okay? And they're going to just, they're just going to make an explosion. So how do you do that? First thing you have to do is you have to have a variable that says turn the explosion on at some point. So you say variable, we'll call it boom. How's that? Equals 0. At this point, boom is equal to 0. There's no value in it. It isn't doing anything. Okay. However, down below, what you do is you say, well, down in silly over here, what you say is, well, if boom equals 1, make this thing blow up. I'm going to say open, shut. Forget what's in there for now, but basically that's the area where it's going to blow up right there, okay? So now what I have to do is I have to set a key that's going to turn boom from 0 to 1. Okay, so let's pick the letter A. It's always easy. A is 65, okay? So what we're going to do is we're going to go up to the keyboard and we're going to say, okay, at the keyboard where it's reading the key stroke right there, see that key hit right there? Be sure you put your mouse in the right place. Put it right after that brace right there, and hit a bunch of returns to open up a space. See, basically, these guys are dependent on that key hit. You want to be sure they're intact and everything's okay, but key hit is the beginning of a function. It's the beginning of the function where you say, what do I do if I hit a key? So we're going to insert ours in here. We're going to put 64 in. We're going to say if keystroke equals 65, right? 65, I believe, is 65. That's A. Then what we want to do is we want to change boom. I want to change boom equals, equals 1. Then I want to return. Does everybody see how that works? How that works out there? Basically, now when I hit 65, the variable boom is going to hit 1. Now when it hits 1, then down here in this program, it's going to say, well, yeah, I hit 1. So I'm going to do whatever's in here. I want to do it. So what you do is you say, in here, I have silly dot sprite ball. Whoops. Dot position. Whoops, not position. Scale. Pardon me. Sorry. Scale. dot x equals plus equals 0.1. Oh, come on, Joe. 0.1. Okay, and I want to do that in the y and z directions as well. So every time it comes into this thing, it won't come in here unless you hit 1, but when it goes in here, it's going to keep adding 0.1 to that number, okay? And it's going to expand. It's going to make the world expand. This is like the Big Bang. That's silly. Soon we'll have galaxies and nebula and all kinds of stuff.
The Milky Way.
What?
The Milky Way.
The Milky Way will be there, and it'll just be quite the scene. Now, let me try this and see what happens at this point, because all I've done is I've simply said, just keep expanding. The universe will never stop expanding. In this case, it'll just blow out, it'll just keep going. We want to stop that, but let's just, for now, let's just let it blow up and we don't care. Okay, so let's see what happens here. I'm going to increase the size of these bricks a little bit. I got them at 8. Let's change them to 16 and make them a little bit bigger so we'll see them better. Okay, there we go. Save. And whatever image you put there makes a difference too, because it affects what the thing looks like. Okay, now if I hit the letter A, something should happen if I did it right. Doesn't like something. Okay, let's take a look at it, see what we got. Something's not right. Okay, I'll have to check out all the code I did just to see if what was wrong. Boom is equal to 0. That's correct. That looks good. Key hit, I say if keystroke is 65, boom equals 1. That's okay, and return is 1. That looks okay to me. See anything wrong there? Looks good. Down here I say if boom equals 1, open shut silly.spriteball.scale.x.y.z. Let's down below, see if I made a mistake down below here. I'm going to change these guys to 1. I don't know why. I seem to recall that I couldn't do it at 0. I'm going to change them to 1 just for, that might be the problem. If it is, it's good to know right now. Let's be sure this is all okay though. Okay, so far. See what happens. That might have been all there was to it. I'm not sure. Oh, actually, what am I saying? It was running fine. You don't see anything because there's nothing there until you press the button. It's so tiny you can't see it. It's only at 1. Shouldn't be black though. It should be white. I don't know why it's white. Let me hit it and see what happens. No, it doesn't work. I did something wrong here. What did I just change? Anything? I changed them to 1. 1, 16's the size. Bricks JPEG. I've got bricks. That's there. Let me change this back to 0. See if I can get this to work again. Because I just made that change. That might be. I don't know why that would affect it, but script. That looks good. Okay. Maybe I didn't save it. Maybe that's all there was to it. Not saving it. I'll try it again. Now if I hit A, nothing happens. I just hit A and nothing happened. Let's figure out why. Why would nothing happen? Let's see what we've got here. Plus equals 0.1. That isn't very much really. Maybe I should change it to 1 to make it bigger. It might be working too hard. Just 1. Let me see if that's possible though. Oh, there's my mistake. You see what I'm doing here? Screwing around with this thing. I should let this be just equal to 0. Let's stay at 0 here, not get crazy about this. Oh, maybe. I would like to keep it at 0. Okay, let's go back up to the scaling thing here. Be sure I did this right. I'm scaling at 0.1. I want to scale at 1. Boy, that should still work. That should still work. Check all these things. Did you see anything wrong in any of these lines here? If keystroke is 65, that looks right to me. Open that. Boom equals 1 and return. And up here I'm saying boom equals 0. And down here I'm saying if boom equals 1, which it will when I hit the key, open silly sprite ball.scale plus 0.1, y 0.1, z 0.1. Let's look down here to be sure this is all okay. Silly equals new sprite sphere 4000. 0, 0 is the starting. Boy, I'm still going to bring those back to 1 again. I don't know why, but I have a feeling that 1 is the minimum size I made that at. 16. Bricks.jpg is correct. Script is correct. I don't see anything really wrong with this. Let's try it again. I could do something different, which there's another thing I can do, but I don't think it should affect it. So I'm going to back up a little bit here. No, it's not. See, it's not giving me. It's not giving me a blue screen, and that says it's supposed to be blue right there. When you're not getting a blue screen, you know something's wrong in your code someplace. Sprite sphere is correct, and sprite ball is correct. Spriteball.scale.x.y is z, that's all correct. Silly's its name, still. Opens and shuts correctly. Boom equals 1. Okay. Okay, I'm going to do something different here. I don't think this should affect it, but I am going to do it. Instead of adding 0.1 to the scale every time, I'm not sure how the computer handles that. I'm going to put another variable right here. Count plus equals 0.1. And I'm going to define that variable up in the general, because every time I come into the function, I want it still to be there. So I'm going to say count equals 0. See, so here's what I'm doing. I'm saying, for some reason, I don't know if it likes the plus sign on the scaling. Maybe that confounds it somehow. It shouldn't though. But now what I'm going to do is I'm going to say, well, count is increasing. I'm going to say, just have it equal count right here. You see what I'm doing? I'm doing the counting in a different place. I'm doing it right here instead of in front of every one of these things. So what I'm going to do is I'm just going to say, replace these with this to see what happens. Okay. Try it and see what happens now. still give me a rotation there for some reason. You guys can't see it, but look up here. See that thing going? It's doing calculations somehow. I wonder if it's just too slow with 4,000 on this machine. That's hard to believe. Unresponsive. Okay, something's definitely not going well here. Find out what it is. Count plus equals 0.1. Count is right. Only if boom is equal to 1. Boom is 0, count is 0. Key hit. If keystroke equal to 65, close, then boom equals 1, return. Boy, I sure don't see anything wrong with that. I say if, oh, yeah, if boom equals 1. It's defined. Count like so. Let's add one more thing in here. If count equals 500, count equals 500, I'm going to try to stop it. Count equals 500, count equals 0, and boom equals 0. Return. No, I don't have to return here. I can just let it go. It's going to be fine. Okay, let's see what happens here. Now what I'm doing is I'm counting. I'm adding to the counter. And then if that count gets up to 500, I shut the counter off and I shut the boom off. So in other words, what happens is it never comes back in here again. Let's see what happens then. That could be it. It could be going out right out of the range. That's possible. Let's see what happens here. If that happens, then I'll explain what happened. I'll explain it to you. Still on the screen. This always suggests there's something very simple wrong I'm just not seeing. Let me just go back at it again. It's trying to do something it can't do. Like, see, it's bricks.jpg is there. Go back down here to be sure. Sprite sphere, we already did that. We know that works. 4,000 particles, comma, starting at 1, 1, outer and inner. And I'll make that 2 just to be sure we got something there. Make that 2. Okay, 16. Size of the thing, 16 is good. Bricks is good. Quotes on both sides. Semicolon is good. Script is good. You don't see anything? I don't see anything at all. Do you see anything that looks weird to you from what we've done so far? Any of this stuff look funny to you? Up in here. This should be consistent with what we've done in the previous. Okay, try it again.
Unless the function render, those parentheses there, is that space supposed to be there?
What'd you say?
Oh, there's like function, render, a space, and then close parentheses.
There it is. We're here. Sorry. That was it. That was it. I should tell you what happened. I'll explain it to you. Hit A. It's going very slow because I just made it go at 0.1. If I make it go at 1, it'll go much faster. But you see it's exploding, the idea. Let me tell you what I did and what changed, made a difference. It was actually a change I made this semester. That's why I didn't catch up to it. This is going too slow. Let's make it go faster. So I didn't have to go out with this business with the count. I didn't have to do that. I just could have put plus 0.1, plus 0.1, plus 0.1. That would work, okay? You do have to put this down here to stop the thing. But let me have it go faster. I'm going to have it go 1 rather than having it go just 0.1. I'll make it go 10 times faster. Oh, let me tell you what's wrong first. Here's what was wrong. See down here, that's the outer ring and here's the inner ring. The outer ring and inner ring were the same. It didn't know what to do. It subtracted them, there was nothing left. So it didn't know where to put the thing. So it became stupid. So basically, you have to make the outer ring a little bit bigger than the inner ring when you do this. That's an interesting point I didn't notice before. Okay, so now we got it. Let's see it work. I want to hit the letter A, hopefully. It'll work. Get back up a little bit here. Pretty pathetic, isn't it? There it is, you guys. That's it. And if you were back away from the thing enough, and you made it go faster, instead of making it go 1, you can make it go 2 or 3, which would be really fast. It would go, boom, it would just explode. Online is 3 or 4 of them I put up there that have explosions in them. That's how they work. Basically, the only thing I want you to remember about this, not the time I took debugging it, but this time right here. Well, you should remember the thing that I made the mistake at, that this number here has to be bigger than that one, because it's creating it. It can't be 0. It's got to be created at some position. And the other thing is up here, you could have, this could just be like this. I'm going to make it simple. You don't need that counter anymore. What you really need is plus equals 0.1, plus equals 1. That'll do it. Let's make it 2 and make it even faster. Plus equals 2. And what that'll do is everything we want. See what happens now. Back up from it. When you hit A, there it is. C'est la vie. That's it. Okay, so there we go. What you'd probably do is you'd have it go out a certain distance, and then just have it stop. So they'd just disappear. This one will do it too when it gets out a far enough distance. That's it. So yeah, I've pretty much done it. So therefore, we have 2 things today that are important. One is you can scale stuff, which is, we're kind of using it in a funny way here. You can scale stuff, and you can also make sprites, which both are handy for, as I say, I could put other programs up there. There's lots of different things I've seen sprites used for. I have a UAV, which is one of these little helicopter devices. I have one that's one sprite. It's a one sprite program, that's all it is. And when it comes up, you can actually manipulate, make it move around and everything, because it just changes the position of all the objects, and the only object is that one sprite. So it moves. I can make it move around, do anything you want. I'll put that one up tonight, and I'll also put down the instructions for this, and I'll make a note of the sizes so you know not to get in that situation I got into today programming. That you have to have, one has to be bigger than the other. The outer radius has to be bigger than the inner radius, or it doesn't work. Okay, that's it. Done.